Hello everyone. This is another way where we are meeting, especially for my general audience. So we are meeting physically, and our online environment is also quite different than this, the general classroom. But today I thought of going for a separate online session. This is to discuss our term test paper. So then you can remember that we conduct a successful term test regarding what we have covered up to now. Simply it was covering up to the logic gates, still the logic gates first part, but now we are about to finish the logic gates, and you all got your results as well. Then I marked those papers, and on the papers itself I have indicated what are the mistakes you did, and hopefully most of the people achieved some moderate level marks, and some people are quite poor. There are people who have scored brilliantly. Then this discussion would be important for everyone, including the people who are not attending to my classes, as well as people who did not do the term test paper. You can download the paper from the link available in the YouTube description. Then you can go through the session lively to identify the mistakes you did, as well as to improve your knowledge behind the first chapter, second chapter, third chapter, and the fourth chapter. Right. So then we'll see how your performance, and we'll see how they are going to be. Right. Then I may go through the questions. Now this discussion, again understand that this is not a theory session. This is a paper discussion. Therefore, I don't explain much more theories like in my class, thinking that you will have the theory knowledge, just explaining the things. That's all we do. Right? Then you have to have, right now these are the older chapters, you have to have the proper knowledge. Right. Normally the first question came from the history. It says that who was the first yes, then it says that who was the first to propose the concept of stored program. Now you can remember the stored program architecture that was invented somewhere around 1940 to 50, not the initial computer. So when the computer technologies were there, you can remember that we had our computer open board මොකදනේ it's right. Okay. Then so we had the development of our computers. Right. So when you go to the development, simply evolving, we said that that goes with the somewhere around Charles Babbage. So he made two machines. One is difference engine and then analytical engine. So the Charles Babbage said that the input process output model. So in his machine he included the input process output concept. That's what. Simply what it does here is, he said that we will make a machine or device. That device has to be inserted with something, the relevant data, instructions, we have to input them. Then the machine will process them. We made the machine to process them, to calculate them, to compare them. And then the processed values are given out. That's what the Charles Babbage concept is. Then later on the stored program architecture came. So then under the stored program architecture, what was included is stored program architecture. Now this was invented by whom? The question is asking, who did so? That is John von Neumann. That's the answer, but I'll revise this part. John von Neumann said that other than this general stored program concept, he said that a memory is possible to be used inside the computer. So he introduced the memory, which is the RAM in our modern days. So that's why we respect the von Neumann's stored program concept. Our modern computers are also using the stored program architecture. So just to tell you that what is the stored program architecture, he said that it is possible to maintain the ordinary CPU, which is having the ALU, then the control unit. So ALU will perform the arithmetic logical processing work, control unit will control the CPU. Then he introduced that something called as memory. This is holding all the inputs we are submitting. What we input are stored in the memory. And then memory will submit them into the CPU to do the processing. Process results are again given back to the memory, and through the memory, that's going to be the output. And now, this is what the stored program concept is. If you have to write this in text, how to write it? Stored program architecture says that all the data, that's worth, I hope that. Now they are given into the notes already, but better to write them, then the things will get into your head better than what you were. Right? All the data and instructions, can be stored within the computer, inside a single memory. So this is what his concept is. Then the memory he is talking about is the RAM. So that the RAM available in the modern days is the one he is talking about. So then this is what the stored program architecture is. Somehow a question is asking who invented this. So then stored program architecture was invented by the John von Neumann. Right. Then the answer for that one is who the first to propose the stored program architecture. The answer is von Neumann. Then there are some other characters in the discussion. Lady Ada Augusta Lovelace. What is the importance of Ada Augusta Lovelace? It is to be set as the first programmer in the history. The first programmer is called as Ada Augusta Lovelace. Then Charles Babbage is the father of the computer. Then Howard Aiken invented the machine. What is it? Mark I. And then Blaise Pascal invented the machine called as Pascaline. Right. So then you understand that this question revises many more things behind the history. Okay, somehow for the first one answer is going to be von Neumann. Then second one, quantitative data is best described as quantitative. Then the other discussion is the data are available in two categories. So simply we define data as raw facts. So then those data are in two categories. One is called as qualitative data. Other one is called as quantitative data. Right? Qualitative data and quantitative data. So give me a small second. I forgot to put the link into the other group. Give me a small time. I'll put it. I have not subscribed to the channel, therefore they don't know how to attend the session. Right, now it's working. Fine. Then the data are raw facts, which are in two categories, quantitative and qualitative. Matakai. Then what are quantitative data? They are the measurable data. Measurable. Simply countable. Data which are countable. called as quantitative. Just like the height of a student. So height is countable. Someone says that 4 feet, right? Then we can say that the money I have with me in your pocket. Then I say that 120. So then that's still quantitative, measurable. Right? And then qualitative means they are not measurable. You can remember that. Measurable. Right? My spelling may be wrong. Cannot be measured. Then by that time, just like the color of the sky, softness of your skin, how soft it is, kindness of a mother, right? So then they are not possible to be measured. How much is it in a value? Kindness, then softness. So then they are raw, not process values, but cannot be measured. If they are measurable, they are going to be called as quantitative. Right. Now the question is about qualitative data. It's qualitative data. Qualitative data is best described as, qualitative means not countable. They are giving a feature but raw. Then numerical and measurable. No, it's quantitative. Used only in mathematical calculations. No, mathematical calculations are supported by quantitative, measurable. Then descriptive values which cannot be calculated. Isn't that? Which cannot be calculated. They are descriptive. They are used to describe. And then always collected through sensors. Can we say that the qualitative data measured through sensors always? Not always sensors. There can be, but not always. Right? Always is the conflict in it. Then express only in ranges. Ranges are a value starting to the ending. That's countable. Therefore, it's not a qualitative. It's going to be quantitative. Right? So then for the second one, the answer is going to be the third one, the correct answer. Right. Now the other one. Okay. Right. Now the question number 3. The golden rule of information suggests that the delayed information is. What is golden rule says that? Golden rule describes the value of information. Just to tell you that, it says that this is the time axis, this side is going to be the value. And now what is it telling? The value of the information reduces over the time and keep it fixed after a certain time. So then this side value of information is presented. Right. Then what is the proper answer for this particular question? Golden rule of information suggests that delayed information is. When the information are going to get delayed, what happens? Always more reliable. So golden rule doesn't talk about reliability. More valuable, no. Less valuable than when first released. Quite fair, right? Golden rule of information suggests that the delayed information is, along with the time, the information value is going to be less valuable than whatever it was released at first. Right? Then equal in value to new information, no. Then not affected by time, no. Definitely it says about time effect on the information. Right. Now the next question, question number 4. Which of the following computer components is most correctly found outside the CPU? Outside the CPU. Right. Then RAM, that's it, right? RAM is outside the CPU. CU is inside, ALU is inside, register, L1 cal, all are inside. Then the answer is going to be RAM, very simple. Now the next question, question number 5. The fastest storage unit built inside the microprocessor is. What is microprocessor means? So microprocessor here, microprocessor means the CPU. So within the CPU, what is the fastest memory available? There are three things. One is control unit, ALU, the other one is going to be the register. And the fastest memory inside the entire computer is going to be the register. Right. So then this is still very simple. The fastest storage unit built inside the microprocessor, that means the CPU, that's going to be the register. So main memory is outside, control unit still inside but not a memory, hard disk outside but not fast like the register, but still it's outside, they want inside. Cache memory, though it is inside, L1 cache is inside, but that is slower than the RAM, slower than the register. Okay. Then question number 6, which of the following present examples of big data sources? This is going to be big data. Now I'll remind the big data point a little bit. When it comes to big data, there should be 5 features. What are those 5 features? 5 V's really in big data. 1, 2, 3, 4, 5. All features should be there to make it as a big data. Simply we said it as value. The specific information has to have a commercial value. Then the other one is volume. Those must be available in large volume, just like terabytes, even petabytes. Likewise, large volume should be expected. Then next one is veracity. What is veracity? Accuracy. Those must be accurate. Then velocity. What is velocity? Those must be updated or created very quickly. Velocity means speed, quicker. Then value, volume, veracity, velocity. What is the other one? Volume. There are 5 V's. It should be having a commercial value, then a large volume, accurate, variety. So the specific data must be in wide varieties, specifically telling about 3 varieties. What are those 3 varieties? Structured data. I'm just reminding this. Then semi-structured data. Other one is unstructured data. What are unstructured data? The data written into a paragraph, just like a newspaper article. It has lots of words written. Out of them, I am going to extract the names of animals. So they are the data. Then that's not structuredly available. So then they are called as unstructured data. Then structured means they are available in tables. Once you put data in tables, very structured, we can access the data immediately. But unstructured means it's not like that. Then semi is not structured like this, not unstructured like this, just like XML data. So we don't go in deep under XML. Now these are the 5 V's of big data. I just reminded you. Now what is it telling? Which of the following represent examples of big data source? Big data source, from where such big data are collected. Then a social media post, isn't that? Whenever the social media posts are added, it may be shared among many more people and it may have many other data behind it. So social media posts are completely going to the big data handling. That's fine. Then a student exam mark sheet of grade 12 students. Is mark sheet applicable for big data? No. Sometimes there can be 40 students, 50 students. Even if you have 100 students, that is not called as big data. So then that's not. Then sensor data from IoT devices. Yes, here we have a certain word called as IoT that comes into the chapter, the latter chapters, but simply say that sensor data. When it comes to a sensor, generally are the sensors giving one value and stopping it, or are the sensors continuously providing streams of data? We use the word stream. If I have a temperature sensor fixed, so that this is a temperature sensor, this is fixed into a computer. Now this sensor, won't it keep sending data to the computer continuously until it is powered? Then after a certain time, there will be millions of data fed. As an example, per second, if the sensor can create somewhere around 100 readings, there are 100 readings read by the sensor. If you go for 1 minute, it's going to be 6,000 data. 1 hour, a big number. So then sensors will keep creating data and leading to a large volume of data. That's true. Sensor data of IoT devices. Forget about the word IoT, Internet of Things. We'll learn that in the future. Then this is still going to be a certain big data source. Sensors are giving you. Just like the GPS. That's also a type of a sensor. Then in that manner, the answer goes for A and C at this moment. Right? Now, some people may not mark this as a correct answer, since you may not know about the IoT word. But you should be able to understand the word sensor. Then sensor is not giving the answers only for one instance continuously for long hours. So therefore, this has a higher value. Right. Then the next one, the 7th question. Okay. Then question number 7 says that firmware is best described as firmware. Still you can remember that firmware are the softwares available in a specific hardware to make it workable. As an example, if I go to a washing machine, this is the same example I took in my theories as well. The operation of the washing machine is completely guided by a software running inside the washing machine. Is this software a Word, PowerPoint like software or specific software for that particular washing machine? That's a fixed software. No need to update it as well. Then that particular software is called as firmware simply, that makes this specific device operational. And that's the nature what this firmware are. That's a fixed software to make that device workable. Hopefully the firmwares are stored into a ROM, so it's a fixed memory to store the values. And firmware is best described as a standalone application software. Can I call it as a standalone application? No. What is the standalone word? Standalone means it's running in our normal personal computer. That's a standalone idea. Right? Not a connected computer. If it is connected into a network, that's not a standalone. Right? Then the program that runs only in cloud. No, cloud has no any relation with the firmware. Program to make hardware device functional, isn't that the answer? It's a program to make a specific hardware a functional or operational device. Right. Then that's question number 7. So we have somewhere around 25 MCQs to continue. We'll go through them. Right. In the given memory hierarchical diagram, which of the following characteristics A, B, C, D respectively? Right. So then this is a memory hierarchical diagram. This is it. here is that increase the speed and the expense. Expense and the speed is incrementing, increase the size and the capacity. Volume is increasing downwards. And normally this has to be the fastest memory. Below that we have cache, and obviously this has to be register. Am I correct? Then after the cache, this is solid state. Solid state is going to be secondary storage. This has to be RAM-like memory according to my knowledge. Then after the solid state, here we have optical. Optical means CD, DVD. So this has to be somewhere like hard disk, which is slower than the microchip based secondary storage. And then after optical, we can have magnetic tape, even magnetic tape. That's the answer, right? What are the points then? Okay. Then A, B, C, D respectively. So A should be a register then. It has to be this, this, or this. Then register, after that the main memory or the RAM. And this is out. Then after that this has to be hard disk and finally magnetic tape. Then the answer goes for the fourth one. Is it? Not the fifth one. Fifth one can't be main memory on top. Right. That's very simple. Then question number 9. What it says is, okay, consider the following statement about cache memory. Now, what is the job of the cache memory? Cache is used to store frequently accessed data in the computer. Then, in our computer, we have RAM and cache. Normally, this is the CPU. Then here we have the RAM, which is external to the CPU. So, the user deal with the RAM. And RAM will submit them into the CPU at a faster speed. Even all the input devices are still submitting them into the RAM slowly. This connection is slow. Other than the RAM, RAM is storing all the running data. It stores all the running data. Right. Other than that, it is possible to introduce a cache memory. Then we know that cache is faster than RAM. Then the job of the cache is to store what? Frequently accessed data. You can remember this. It is to store frequently accessed data. That's the job of the cache. Then by the CPU, if there are some data which are repeatedly, frequently being accessed, they are going to be kept on the cache, which is faster than submitting them into the CPU. And the cache memory outside the CPU is called as L2 cache. It is possible to have cache memory inside the CPU, which is called as level 1 cache. Matakayo. L1 cache is faster than L2 even. Somehow, altogether, cache memories are faster than the RAM. But among all of them, there's another faster memory inside the CPU, which is called as register. So, register is said to be as the fastest among the computers. Right. Now, with that knowledge, we'll take the question. Consider the following about cache memory frequently, right? In a desktop computer. L1 cache memory, L1 that is inside the CPU, has more capacity than L2 cache memory. Then when you go for L1 cache and L2 cache, this is faster than L2 cache. This is slower. If so, which one is expensive? L1 cache, the L2 cache. L1 has to be expensive than the L2. L2 is going to be quite cheap, not very much cheap, little bit cheap, not cheaper than RAM. So since this is cheap, L2 cache is available in quite larger memory than the L1. And this has a larger volume than this. Why this is expensive? Since it is expensive, can't afford a lot. Then compared to this, it has a smaller volume. Alright. So then, based on that particular point, L1 cache memory has more capacity than L2. L1 has more capacity. The capacity means volume. No, that is wrong. Reverse, L2 is slower, so L2 has more capacity than L1. L1 cache memory has more data accessing speed than L1. Yes, L1 is faster than L2. That's true. Cache memory is made up of static random access memory, SRAM. Yes. Still you can remember that we told about two memory types, DRAM and SRAM. Right. Just to revise that as well, when you go for SRAM, static random access memory, and dynamic random access memory, out of these two, which memory has to be refreshed? DRAM has to be refreshed. This is not, no need to refresh. Fine. Then due to the refreshing, the data handling speed of DRAM is slower than this. Why? We want to rely on the refreshing. So this goes for slower than the SRAM. This is going to be faster. And SRAM is made up of, SRAM is used to make the register as well as cache. Among the cache, we can say that L1 cache, which is inside the CPU. Then DRAM is used to make the RAM, or simply the main memory of the computer. That's why SRAM is quite slower than the cache as well as register. Right. Then based on that, what can you mention? Cache memory is made up of SRAM. Is it made up of SRAM or DRAM? It is SRAM, that's possible. Why? L1 cache is made up of SRAM. That's fine. And the answer goes for B and C in it. Fourth is the answer for the question number 9. Yes. Right. Then we are moving into the next question. Question number 10. If you have doubts, it's better you can put a comment on it, or else people who have my contact number, you can WhatsApp me about the questions. I'll try to solve them at the moment. Then question number 10 says, which of the following is correct? They want the correct statement about the functions of basic input-output system, BIOS, in a computer. What is this BIOS used for? Just to explain, basic input-output system, BIOS is stored in which memory? In a ROM, read-only memory. If so, no one can change, no one can modify that. Then by that time, this is used mainly in the computer to store boot up process of the computer, or boot up program of the computer, starting up program. Hurry. Then the steps are, when you turn on the computer, initially BIOS is going to get activated. And within the BIOS, we have another subprogram to execute next, which is called as post. Hope that you can remember. What is that? Power on self test. Post means power on self test. Then that will check whether all the main components of the computers are working properly. And BIOS is basic input output system, that is arranging the configuration within the computer. Then after that the next program comes called as CMOS. මතක නැත්නම් මේ ටික ලියා ගන්න දැන් ආයෙත්. Right, no need to revise again by going through the note. Then CMOS stands for what? Complementary metal oxide semiconductor. Then what is the role of the CMOS program? Now that is being used to hold user defined settings. It is based on a battery power, the small that silver color battery fixed into the motherboard. I told that already. So this is holding or storing user defined settings. Just like the boot up order, the system clock. So these are going to be held in the CMOS. And based on the CMOS settings, it is held in the boot up order. Then the operating system will get started to take the control of the computer. And now these are the steps of starting up process of the computer. We call this as bootstrap. So bootstrap is a short term for the boot up process of the computer. Still, these are common questions found in our past papers. So be ready with these steps. What are the steps to be continued? Right, now the question is quite different. What does it say? Which are the following correct about the BIOS? It is used to control the entire computer. Is it? It is used to control the entire computer. It controls the whole computer, such as control all the hardware, software of the computer. Who controls all the hardware and software? BIOS or operating system. That is completely up to the OS. Right? OS is doing the controlling job, not the BIOS. It provides a program for central processing unit to communicate with other devices. CPU will communicate with other devices. We'll see. Then it provides memory space to load the applications for the hard disk. Is that allocating the RAM memory space? No, it doesn't do like that. Then it provides electric power to start the computer. No, power is provided by whom? The power unit, the switches. Then it provides a memory space required for computer during the startup process. Is that providing a memory space to start up the computer? Or isn't that having some coordination among the components of the computer? It has, right? And this is still not the answer. Second one is the answer, right? For the question number 10, it provides the provides the program for the CPU to communicate with other devices. I said you that when you go for the BIOS, the CPU is available here. Then CPU should detect that I have a RAM like this. These are the addresses of the RAM. Then I have a graphic card like this. So then graphic card is of this capacity. I have a keyboard like this. So then that understanding among the components is done by the BIOS program. Also the buses, the data bus, the width, likewise. And in it, the answer is correct. The second one, it provides a program for a central processing unit to communicate with the other devices. Fine. Now the next 11th one, consider the followings. Which of the above are volatile memories? What are volatile? Whenever we switch off, data will get erased. Non-volatile are, though you switch off, data will be stay. Hard disk, non-volatile. CD, non-volatile. When you take it out from the computer, still the data will be there. Non-volatile. Volatile means when you switch off, data will get erased. And now, RAM, that is volatile, yes. Hard disk, no. Register, yes. Cache memory, yes. Flash memory, not. Why flash memory? Flash memories are microchip based secondary memories. Just like pen drive, even memory cards, just like micro SD cards, SD cards. So then they are going to be the flash memories. Therefore, volatile memories are A and AC and D. So then 3 should be the answer. Right? Now question number 12, consider the following statements. Which of the above are correct? When you are doing questions like this, these are having statements. It says that consider the following statements. Consider. Then before reading the statements, read the question. What have you to do? Sometimes they ask, find the incorrect answers. Find the incompatible statements. Therefore, before reading, get the command what you should do. Which of the above is correct? Now we want to select the correct statement. Then fine, we read it and detect whether it is correct or wrong. Then we can accept or reject it. And it is not necessary to obtain legal permission for the use of proprietary software from the respective owners. What are proprietary softwares? Licensed softwares. License means, are we free to use them or we have to pay and get it? Pay and get it. Then it is not necessary, they said not necessary to obtain legal permission for proprietary. Proprietary means paid softwares. When you are going for paid softwares, definitely we have to pay and get the license. We have to get the permission. And now, it is not necessary, that's wrong. If so, what is it called as? We are going to use proprietary software. We are going to use a proprietary software without the permission, without the license. What is that even called? That is called as software piracy. Right? So then that's called as software piracy. Okay, then somehow that's invalid. Then all the open source software are always free of charge. Open source softwares are always free of charge. What are open source software? Open source means, you can remember that regarding softwares, we are going to categorize them into few categories. One is proprietary software, which are also called as licensed software. Then you have to pay and get it. At that moment, they will give you the software only, nothing else. They give you software. Then we have the other software category called as freeware. So that those softwares are freely available for us to download and use. Just like WhatsApp, Google Chrome. So we get them free, we don't need to pay. Right? So then freeware are examples just like WhatsApp. Likewise, there are many different free games, Google Map. So they are free to use. Then after that, FOSS, the other category. Now I am quickly summarizing these areas. FOSS stands for free and open source. Then what is that? Those products are free, that means we don't need to pay, no need to pay. Open source, that means the source code of the software. You can remember what the source code is. What is source code? The code written by the programmer. Programmer is writing a code in English, just like print, having keywords, then if, while. So those codes are given, and once you run this code, then only we get the final software product. As an example, if I am to get Photoshop, so this is what the software is. But this is a Photoshop software. This Photoshop software has been created by writing this sort of codes. Since Photoshop is a proprietary software, you get only the software product, not the source code. Then, if the software is going to be treated as FOSS category, the software is given for free. Even open source means the source code of the software is also given for free. So this particular source code is also given for free. Then the user can use this product. Also the user can update the source code and handle that. So there are the versions called as FOSS. But in this question, they don't talk about the free and open source. Instead, they go for the tricky point. All the open source softwares, will they say that FOSS or just open source? All the open source software are always free of charge. They don't say FOSS. FOSS is free and open source. Open source means, it uses the word open source, that means source code is given. But it doesn't mention whether it's free or not. Therefore, we can't say that all the softwares where they give the source code are for free. That's not guaranteed. Right? In that event, this is still going to be wrong. But if this is to say that if all the FOSS softwares are always free of charge, that's perfect. But now it's not. Right. Then open source software give more rights to the users while comparing to the proprietary software. Open source software gives more rights to the user. Open source, yes, they give the source code. Legally, then I am eligible to update that. I am eligible to work on it. Unlike the proprietary. Proprietary, they give the software only. And this C is correct at this moment. Answer is going to be C only. So then for the question number 12, it's C only. Fine. Now the next set of questions. Question number 13. Presence check is mainly used to ensure that. Now this is regarding validations. I'll quickly revise that validation part as well. Validation rules. Now these are used whenever the data are entered into the computers. Here we have the computer. When the data are entered into the computer by a user is going to enter data, so that within the computer there has to be a data entry form. Software has to be there to accept the data. So it asks say that we have to collect the name of the user, then the date of birth, sometimes the age, the telephone number, NIC, and then finally we have said that the button called as save, then the next button, go to the next record, the previous button to go to the previous record, likewise. So this is a data entry form. So when person is typing data onto this, sometimes the person may make data entry errors. Simply at the place of the name, mistakenly person will type a numeric value. Normally we accept only the letters. If so, into this name field, what type of validation you can apply? Type check. Then for the date of birth, we can define a certain value range. The date of birth for a student has to be above this date. Why? They have to be above 5 years. And date of birth should be not above, below. Now we can have a range check to say that what range of values are accepted to the date of birth. Then age, still age has a range. If it is a student in a school, from age 5 to 20. And this is still going to be going for the range check. Hope that you can remember. Even for the telephone number, we can apply two rules. One is length check, accepting 10 characters, and also we can accept type check, telling that only numbers. Then NIC, still we can go for a length, how long it is. Further, when we are inserting this data, still we can say that parallel to the data entry, the name of the person has to be definitely available. Then we can use a presence check there to say that this is a compulsory field. Also, NIC has to be going with presence check since the data are essentially included. Then matak kela enawa. This I am just giving the example and the background. Right. So then these are the some of the type of validation rules to be used. Fine. Now yes. So if you have doubts still in YouTube, you can put them into the YouTube chat. I can see them. Right. Now the question is about what? Presence check. Question is about the presence check. This is applicable for compulsory fields, presence. Okay. It says that presence check is mainly used to ensure that presence check is mainly used data within the fixed range. No, that is range check. Data matches with required type, that is type check. Field is not left blank, isn't that? Can't keep null, can't keep empty. So then for the 13th answer is going to be 3, a very direct question. Data flows predefined patterns. Patterns, if the data has to have a certain pattern, we can say that a type check, range check. Pattern, we can say that, what is that, can't remember. Okay, then pattern. Say that it has to have a pattern A001. This pattern has to be followed. What is that validation check? No, it doesn't come to the head quickly. Wait, I'll cover that in a while, right? So data stored securely, that's not a point here always. Somehow 13th answer is going to be the 3, right? Order. Okay, let it go. Then the 14th, which of the cloud model provides access to fundamental computing resources such as virtual machines and storages, right? Then for the 14th, what is this talking about? Virtual machines and storages. They are asking cloud computing models. So when you go for cloud computing, there are different models available. 3 models: IaaS, SaaS, PaaS. Infrastructure, IaaS. So in cloud, there are three categories: IaaS, then SaaS, as well as PaaS. Infrastructure as a service, software as a service, platform as a service. Right? Then infrastructure talks about the computing infrastructure, the CPU, the RAM, the whole computer, storage. Right? So then they are going to be infrastructure, storage, then CPU power, the RAM capacity, all are falling under the IaaS. Then software as a service means we are going to go for the software applications to be accessed as cloud. Cloud matakaini. So then here we have the user, So then the resources are not installed into the local computer. Instead, they are available through the internet to access, providing through specific servers. That's a cloud facilities. We don't use them in our local computer. We are going to use them from the server itself. Now, if it is going to be infrastructure as a service, the computing infrastructure, the storage, the CPU power, the RAM, that is going to be used through the cloud. Software as a service means the server is holding running softwares. They are going to be accessed through the internet to the user's computer. Then platform as a service means into the computer, the specific platform is available. So that particular platform is going to be provided to the user, just like the entire working environment platform is that. The working environment. Therefore, I am quickly rushing through this just to remind them. Working environment. Example regarding the software engineers. Regarding software engineers, they need the running environment, testing environment. So then those packages are completely available in this platform. Then they are going to be accessed through the cloud. So then there are the three categories, a quick reminding on them. Right. Now, what is the point? Which of the following examples of which of the following are example which cloud model provides access to the fundamental computing resources? So computing resources in the sense, hopefully, what is it? Infrastructure, right? Resources of the computer, CPU, RAM, things like that. And that's going to be infrastructure as a service. 3 is the answer, not anything. So we don't have something called as DAs, FAs, A1A, just filling the answers. Then 15th, which of the following examples belong to a platform as a service? Then it provides a working environment at the server. We are going to use them here in my computer. And now, virtual machines, deployment tools, computer relations CRM, online storage, word processing software. So word processing software is no longer a platform, it's just a software. It goes for software as a service. Then online storage, that means just like Google Drive, that belongs to infrastructure as a service. You are going to get the storage infrastructure. Then virtual machines, that is still going to give you the infrastructure. Virtual machines and storages. It's a imaginary machine, still infrastructure is given to you. That's also infrastructure as a service. And what is the CRM? Customer relationship management. Really, we have to discuss them in our future systems chapter. That is also a software package. Right? So then these still belong to the software as a service. Deployment tool means a certain software developed has to be delivered to the customers in a proper order. And that is a certain working environment discussed. How to make that available to the users, how to release them as a final software package. So that the answer goes for the deployment package, deployment tools, the second one for the question number 15. Yes, all the others are. Now, though you don't know this deployment, you can filter the wrong answers given. They ask platform. Virtual machine is never. Storage is also not. Word, this is customer relationship management, that's a software. Sometimes this may be doubtful for you. Either this or that. Then I have to filter this as the answer. Okay. Now the question number 16th. Use of the software by others without the consent of the legal owner is called. Using a software without the consent, without the permission of the legal owner. Software piracy. We said that. 5th is the answer. Then these words are quite new to you. Plagiarism is what? Plagiarism, we did it. That is use of someone else work as my work. Then not the plagiarism, phishing and still you don't know. Open source is the software category we said earlier. Proprietary is the software category we said earlier. Right? Answer is going to be the fifth. Digital divide refers to, can you remember the digital divide? So digital divide defines the gap digital divide is providing the gap in between whom? The ICT literated group, and illiterated group. So then there are people in a country, you can remember that I just had the same explanation. If this is Sri Lanka, the available population can be in two categories. One category is literated in ICT, other category is illiterate in ICT. They are not aware with ICT. Then this gap is called as digital divide. Right. Now, what is the point there? Digital divide refers to sharing of digital devices among families. No. Inequality access to ICT. Isn't that the answer? Inequality in access to the ICT resources. Inequality of ICT resources. Then the method of reducing ICT rules. No. Type of computer network, digital communication rule. No. The answer is going to be the second in it. Then 18th. The 2's complement of 10 and 18 are respectively. Now this is a mathematical work. That's very simple in chapter 3. 2's complement of 10. So 10 in the sense it's a positive number. So how to go for the 2's complement of 10? That's a positive number. And what is the 2's complement of positive number? Direct binary with 8 bits. Right. Now to convert that into 10, 2, 4, 8, 16, 32, 64, 1 to 8. They are the 8 bits. I want to produce 10. 10 means 8, 0, 1, 0. This is 10. So I must complete the 8 bits by adding zeros to the front. Then the next question is 10 and minus 8. Other one is minus 8. And now minus 8 in 2's complement. Now this is going to be a negative value. If so, what is the procedure? Write the magnitude in 8 bits, invert it and add 1. Then you have to write the magnitude 8 in binary. The place values are 1, 2, 4, 8, 16, 32, 64, 1 to 8. To complete 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. And now 8, this, so I have to complete that with zeros to the front. Now what is the next thing to be done? We have to invert the bits. And then we are going to add 1 into this. 1 plus 1 is going to be 0. Sending 1 will make it as 0, 0, 1, 1, 2, 3, 4. This is what minus 8 is. Then they ask the 10 and minus 8 in 2's complement. Then which is the answer? Isn't that the fourth one? Yes, fourth one is the answer, right? So then this is the order how you get it. So then with that, this is going to be the answer. You may compare that. Now since they are in two places, I can't compare together. Fine. Then which of the following are equivalent to octal 152? Then they are giving us the value 152 in octal, binary answer, decimal answer and hex answer is given. Right. Then I'll quickly do the rough work somewhere here. If it is going to be 152 in base 8, I can easily convert that into binary. Since it is base 8, each digit has to be written as a 3-bit binary number. And 2 is going to be written like 0, 1, 0. Then 5 has to be written like 1, 0, 1. Then 1 is going to be written like 1, 3 zeros, 1, 2 zeros. And that is what the binary answer is. Is that correct? The binary is 0, 0, 1, 1, 0, 1. So binary is correct, right? Then I may check that into a hexadecimal. How to convert binary into hexadecimal? Break this into the blocks of 4 bits. 1, 2, 3, 4. 1, 2, 3, 4. And convert each block into its decimal. Then this is going to be 1, 2, 4, 8. This is making it as 10. 10 in hexa means A. This is 1, 2, 4. That's going to be 6. This is 0. And now 0, 6A is the hexadecimal answer. That's also fine, right? 6A, front zeros are neglected. Now I want to check the decimal answer. Now when I go to the binary value, I'll rewrite that binary value, this one, skipping the zeros at front, or I'll keep that 0, 0, 1, 1, 0, 1, 0, 1, 0. Then the place values are 1, 2, 4, 8, 16, 32, 64. So this is going to be 96. And this is 10. And now 106 is the decimal answer. That's also fine, right? And now all three are presenting the value of 152 in octal. So answer is going to be the fifth of that question. Now this is a very simple question. Just to do the rough work and get the answer quickly. When you are converting, it's worth converting them into binary to save your time. And that binary answer can be quickly converted among the other values rather than converting the octal answer directly into the others. Yes, thank you. Someone helped me that the earlier one, the check, the format check, right? Yes, thank you. Where I skipped that? Where was it? In a certain question, I was stuck telling that I can't remember what it is. In question, this one, right? So now this is going to be the format check, right? Thank you, Pate. The different patterns are there. That is for the format of the values. Format check, right? Okay. Then this is about the octal question. Now the question number 20. Yes. The 8-bit ones complement number corresponding to the decimal value. Now this is 8 bits ones complement. What is that? The value given here is this. That is given in 8 bits ones complement. And now 1, 2, 3, 4 likewise. So I'll write that in the other board, then that could be easy for me to work out. 4, yes, I have that. 4 1 0 1 1 0. 1 2 3 4 0 1 1 0. Now this is given as 8 bits ones complement. Right. Now this ones complement answer has the MSB comes as 1. If MSB is 1, is this value a negative value or positive value? Even in 2's complement, if this is 1, this is going to be treated as a negative value. So negative means in 1's complement, if I am represent somewhere like -7 under 1's complement, what do? I write 7 directly in 8 bits. 7 would be 1 1 1. Then 1, 2, 3, 4, 5. 2. Since it is negative, I have to invert bits. 1, 2, 3, 4, 5, 6, 7, 8. That's all. Alright. Then here, this is an 8 bits ones complement answer, where the MSB is 1. And this is negative. To get the magnitude, what do is, I just flip the bits, invert the bits, and directly go for the decimal conversion. And now, when I flip the bits or invert it, this is going to be 4 zeros, 1, 00 and 1. No need to have any adding 1 since it is 1's complement. And now the binary values are 1, 2, 4, 8. This is going to be minus 9 as the decimal answer. Fine. Right. Then in it, this is 1's complement, so it would be this. Then the next one, 21. Which are the following equivalent to this? Now they are giving us one another decimal answer going to be 6.25. In decimal, we are supposed to convert them into binary. Then, how to convert decimal fractions into binary? Whole number separately, fraction separately. 6.25. Matakada karana hati? Here, when it comes to 6.25, when converting that into binary, so we have to go for the whole number here. This is being converted into binary separately. That is in the usual order. Then that's going to be the place values 1, 2, 4, 8. 6 means 1, 1, 0. Then we have to go for the fractional part to be converted into binary separately. What is that? That's going to be by multiplying the fraction until we get the fractional part as 0. Then the work is going to be 0.25. This is a fractional part. We have to multiply that by 2 to bring that into binary. And now that would be 0.5. Then this 0.5 is brought to the next level, multiplied by 2, going to be 1.0. Now my fraction has become 0, so that we have to consider the whole part from top to bottom as the binary answer. And now 0.25 in decimal is equivalent to 0.01 in binary. Now we are going to merge them. This is going to be a 0.01, and the final answer is going to be 110.01 is a binary answer. 11001. Then 11001, this is the answer. 6110, yes, this is there, but not 10, it's 0.25. Right, now the next one, 22. Which of the following shows the correct bit allocation of IEEE single precision? Right. In IEEE 32 bits, single precision means 32 bits. What is the order? First we go for the sign bit, after that we go for the exponent, and then the mantissa. Exponent at the middle, mantissa at the end. And now here sign, exponent, mantissa, 3 is the answer. They are very direct questions. Right. Then 23. Right. It says what is the output Z of the following combined logic circuit? What is it? Here A is submitted, then through the NOT gate it becomes A bar. And from the other channel, the B is reached as it is. This C is going to the next AND gate. And this is O gate that will produce the O operator going to be A bar plus B. And that A bar plus B is submitted to the AND gate with C. And the final Z is A bar plus B into C. This is AND gate, it's going to be with the AND operator. This is O gate going to be with the plus operator. And now A bar plus B into C, answer is going to be the fourth. A direct question, very simple. Right. Now the 24th question. Consider the following logic circuit. Which of the following statements is correct about the relationship between input and Q? A0, B0, C0 and then Q is 1. Then what to do? You better substitute each and every input and get the output. But to save your time, just observe this. Right? Here, to make the Q value as 1, this is O gate, any of the input channel have to be 1. Since it's a O gate, if the Q has to be 0, both the channels must be 0. When the output is 0, somehow if this is going to be 1, it will not happen. Through this branch, if 1 comes, Q will not be 0 forever. And if I go into the other way around, if A is 1, since it's the AND gate, can I say that this is going to be 1 always? I can't. By that time, B should also be 1. And now, A should be 1, B should be 1 means this channel will produce 1. AB 1. By that time, the Q has to be definitely 1. Am I correct? Just my observation. If both A and B are 1, this produces 1. Since it's a O gate, now the answer is 1 always, whatever the other branch is. We'll filter such an event. Now, here it says that Q is 1, AB 0, don't know. Q is 1, here we don't, that part is avoided. Now, in this case, we can say that A is 1, B is 1. A is 1, B is 1, C is 0, then Q is 0. Can't I say this is wrong? If A is 1, B is 1, definitely the Q has to be 1 since this branch gives you 1. This is O gate. Now, whatever the other branch, it has to be 1. Then 5 is wrong. Even in this case, second one, A is 1, B is 1, Q is 0. Can't be, it has to be 1. And that is also completely wrong. I filtered them. Now the other place, A0, B0. Then we don't know the rest. Now I think we have to run through that. Yes. Then I will go to the first one and see whether it gives the expected answer. Okay, we'll see. Now I am going to go for the first one. A is 0, B is 0, C is 0. Then we will see what Q is. A, B 0, and this is going to be 0. Then that 0 comes to this. This 0 goes there. This is making it as 0. This is 0. This is still 0, 0, 0, 0, 0. Finally, it's going to be 0. And now all 0 now Q1 lu. No, that's also 0. Now this one A0, B0, C is 1. Now what is it? A0, B0, we'll see. A0, B0, then this is going to be 0. Now I am in the third line. And C is 1. Then this channel gives 0, this channel gives 1. 1, 0 is going to be 1. And this is going to give you 1, this is still going to be 0. Through the AND gate, this makes it as 0. And finally, this is going to be 0. Altogether, the answer is going to be 0. And now, A0, B0, C1, answer has to be 0. A0, B0, C1, answer has to be 0. And now, make up varadi. And what is the answer? The fourth one. Right. Then since all are wrong, we have to go for fourth as the answer. For 24, yes, fourth one is the answer. Now, no need to argue that. Since all are wrong, we have to select the fourth. If you want, you can check that. Definitely, it should give the correct answer. Right. Now, I don't want to do it. Fine. Now, we are moving into the next part, 25, the last question under the MCQs. Which of the following two input logic gates are producing the output 1 when the, right. Now, they talk about a certain logic gate. It has two inputs, A and B, and the output will say Q. Which of the following two input logic gates are producing the output as 1 when the inputs A is 0, B is 1? When you submit 0 and 1, which gate is giving you 1 as the output? O gate, isn't that? O gate, if any of the input is 1, output is 1. Enam first one එක හරි. Exclusive O gate, isn't that? When it comes exclusive O, if it has odd number of ones as input, output is going to be 1. And this is also going to be fine. Even a NAND gate, so NAND is the inverse of AND. 0, 1 means AND 0, NAND is going to be 1. And that's also fine. So the answer is going to be the fifth. All are giving the expected performance. Very simple. Not only O gate, just try with the other gates and find out the answer. Right. Now this is a MCQ discussion. So then I think this may revise your theory knowledge, since I have covered some level of theory background when I am having the discussion. Right. Now we'll quickly moving on to the other essay type questions, the writing questions. Overview of the diagram of an operating system is given below. Write down the labels A, B, C, D, choosing the words from the list given below. Now there's a list available. You have to mark what they are. This is a general flow diagram. Here we have users. Here we have CPU, RAM, I/O. So this is going to be somewhere like hardware. These are softwares. Softwares are having multiple categories. And now the letter D, won't it specify it as hardware? So then letter hardware is there. Word hardware is given. Application software, system software, operating system, they are the words. And what are they? This is software. Which software is interacting with this hardware? Can C be application software or operating system? Definitely C has to be OS. Right. So C is going to be the operating system. Why? Operating system is controlling all the hardware and software, OS. And now A and B are going to be application softwares. Also those can be some level of system software. Just like the defragmentation software, antivirus softwares, still they do a certain service to the user, unlike the operating system. And now A can be application software, B can be system software. You can't say C as system software, right? Now specifically this is a category of software. This whole thing is software. Now this is the level which is interacting with the hardware. Hardware interactions. So then hardware interaction is completely done by whom? Operating system. So this has to be operating system. Right? So there are some system softwares to interact with the user, just like antivirus software, defragmentation. So then they are serving to the computer but getting the commands from the user as well. Antivirus software will scan the computer for viruses based on the commands given by the user. And now this has to be system software, or A has to be system software. So this level A, B can be application or system. It's okay to swap them even. Right. Then what is next? Give two differences of bespoke software and COTS. What are bespoke software? Yes, bespoke software and commercial off-the-shelf software. You can remember that bespoke softwares are the softwares made or constructed focusing on to a specific business. So as an example, when it comes to banks, so they are running a bespoke software which is not available in the shop to purchase. So then they will cover all their requirements. Just to give some details, they cover all the requirements. Right. And further, what else is there under the bespoke? They are expensive or cheap? Expensive. And it will take long time to complete the software. And the software can be modifiable to match with the business changes. If the business patterns are changing, it is possible to upgrade the software. So then the possibility or possible to change the software according to business changes. So then that's the nature of the bespoke. Then the opposite category is, what is that? Off the shelf. Now they are the examples of Photoshop. Ne? Even MS Word. Now what happens is, those softwares are made by the manufacturers and make them available for people to use it. So they are covering the general requirements, not specific requirements of you and me. Right? Then simply it covers the general requirements. Then they are cheaper. Then hopefully may not match with all the requirements, not cover all the requirements. So that's the difference among off the shelf and bespoke. I just took some of the features among them. Right. Then what is the question about give two differences between bespoke and COTS? Then we can list those differences in that manner. Right. So then these are possible, right? Covers all the requirements, expensive, takes long time, possible to change according to the business changes. Then here covers the general, cheaper, and can get it quicker. So these are some of the points. Just to compare, only 2 points behind that. Right, what's next? List 3 main services of cloud computing with an example. 3 services of cloud, we said that already. IaaS likewise. Then what are they? One is IaaS. So that's enough, right? No need to write infrastructure service. If you write it, that's good. Then example for this one is cloud storage. Ne? Cloud storage. Just like Google Drive, that's also possible. Even Dropbox, iCloud, you can write anything. Then other one is SaaS, software as a service. Right. Then what are such examples for software as a service then? That's going to be Google Docs, Google Sheets, right. Then the next one is platform as a service. That's going to be somewhere like Google Apps Engine. They provide a certain complete working platform. So I gave those examples when I'm having the discussions as well. Then AWS, Amazon Web Services, AWS, yes, Amazon Web Services, still giving you some platforms to work with. Right. Now the other point. Now there's a small discussion to be continued under this cloud storage, just like Google Drive and Dropbox. We'll cover that later, right? For the moment, we'll keep those discussions as it is, as the examples. Then the next part, mention that each of the following statement is true or false, whether they are true or false. ASCII is a coding scheme used to represent characters using binary values. ASCII is using a coding system to represent characters, letter A, letter Z, in binary padlibs. Yes, ne? How many bits are there in ASCII? It's a 7-bit value. Then this is going to be yes, it's true. Right? So you better write whether it's true or false. Mention each of them are true or false. So then, according to the serious marking schemes, you must write the given values, right? True කියලා දීලා තියෙන්නේ. So that you have to write true, nothing else. Even I have accepted that if you put a tick or anything, but the best word is to write true in it. Then RAM is a type of non-volatile memory. No, RAM is a volatile memory. Then this is going to be false. Then an SSD has no moving parts, unlike traditional hard disk. What is SSD? Solid state storage device. Yes, they have a microchip, not moving parts. Yes, that is true. Then the first generation computers use transistors. No, first use vacuum tubes. This is false. They are very direct. Then a GUI allows users to interact with the computer using icons and menus. Yes, graphical user interface has icons, menus, buttons, many more. That is still going to be true. Right. Now choose the appropriate words from the list below to fill the blanks. Write the appropriate in each of the space. Right. Then how to fill that? Is an output device used to print information on paper to obtain a hard copy. What is output device to print information on a paper? Printer, right? Laser printer, blue, we have laser printer, right? And we have write 7 there. They have given laser printer, a category of printer. Is the ability to view software programs and use them. You can also use it for free. Is having the ability to view the software programs and use them. You can use the software. Also, it's for free. So it's a freely available software, may be called as freeware. Blu-ray from application. Then answer has to be the open source software, right? No any other direct word, and I will fill that as 4. Right. Then is a device that uses light to scan. It uses light to scan marked data on piece of paper. Marked data. And what's that? Optical mark recognition. It has the word marked, not the characters. Therefore, it has to be 6. Then a suitable storage device for transferring files with capacity of 28 gigabytes. Suitable device to transfer this much of gigabytes. Then a Blu-ray disc is still fine. Prom not. Prom is a programmable read-only memory. display EEPROM, laser printer OCR. Then we can select a Blu-ray since it has the storage capacity somewhere around 50 GB, 30 GB. Also we can say that erasable, electrical erasable program read-only memory, that's also fine. Therefore, for the fourth one, it's possible to have the answers like Blu-ray, yes. So, one is possible to have, or else it's possible to provide fifth as the answer. That's also capable if you go for a pen drive having the higher capacity. But a suitable storage, they don't say most suitable, they are suitable. The only ROM memory that can be erased by electricity is memory that can be erased by electricity. Now that has to be directly electrical erasable programmable read-only memory. So then there the answer is going to be 5 definitely. Now since you have to use 5, it's not fair to use 5 there, but no worry, we will accept it. Right. Now moving into the other question, question number 2. Write down 2's complement representation of 24 in 8 bits. Write down the 2's complement representation of minus 83 in 8 bits. Right. Then that's a generic question. 24 has to be written in 8 bits. in 8 bits. 1, 2, 4, 8, 16, 32, 64, 1 to 8. To write 24, 16, 8. Then you have to go to the inversion 1, 1, 1. Sorry, this 24 is at negative or positive? Positive. If so, do we do inversion? No, never. Right. So then you are not supposed to do the inversion since it is a positive value. So then directly it goes for this as the 24. Then the next to convert is minus 83. So minus 83 is negative value, so you have to write 83 at first. 64. This is going to be 9, 19. 16 and 3 more. Then for this we have to go for the inversion. Right. Now we want to invert the bits or flip the bits 1, 0, 1, 0, 1, 1, 00, and then we are going to add 1 into this. Now the answer goes like 1, 0, 1, 1, 0, 1, 0, 1. This is what minus 83 is. So we got that minus 83 as well. Right. Then part B, compute. This is part B in the question. This is part A in the question. Then part C says that compute minus 83 plus 25 using the representations A and B above. And now we got 83 like this 1 0 1 0 1 0 1, that is from the second expression, and then we are going to go for 24. This is going to be a minus 83 value. Then 24 goes for the first value 3 zeros 1 3 zeros. That is from the first expression. Now we are supposed to add them together. These two are going to be added or summed together. Then the answer goes like 1 0 1. These are going to be 0, sending 1 to the next column 0, sending 1 to the next column 0, 1 there and 1. So then this is the final answer after the computation. Then that is part C. Then part D show that the answer you obtain. Then part D show that the answer you obtain in 8 bits 2's complement is similar to the decimal answer expected in the arithmetic operation. Now I have to show this binary answer is equal to the decimal answer. What is the decimal answer of this operation? Then this is minus 83 plus 24. That's going to be a minus operation. So then 83, 24 gone, 9. This is 5. It has to be minus 59. Now they want us to show this is equal to minus 59. There what you do is, our answer is 1130101. So I am going to the next page. 1130101. Answer is 1130101. Now still what we can do is, we can observe the MSB here. So MSB is 1, that means this is going to be a negative value. This is negative. Since it is negative, what we do is, we just flip the bits. Going to be 0, 0, 1, 1, 0, 1, 0. And then we are going to add 1 into this to get the magnitude. 1, 1, 0, 1, 1, 0, 0. Now convert this in decimal. 1, 2, 4, 8, 16, 24 and 27. So this gives you minus 27. Then the answer we obtain here still is going to be minus 59. What went wrong in it? Yes. 3 zeros, that my answer is wrong, right? Here it's 1130101. Double one 30101. Right. So that we have to flip it. Right. Now into this we have to add 1 into this. Now the answers are going to be different. Then 1, 1, 0, 1, 2, 3, 0, 0. Place values are 1, 2, 4, 8, 16, 32. This 48. This 31. Then this is going to be 40, 56, 59. Right. Minus 59. That's fine, right? Now this working is expected under the part D of the question. Right. Then they are okay. Now I skip a certain 0 as a mistake, and hope that you got the error and you got it corrected. Then the part E. So state one advantage of using 2's complement representation of data in internal operations of the computer. What is the benefit of using 2's complement into the operations of the computer? So the main benefit there is, whenever we have the CPU manufactured, it has to have an ALU. So under the ALU, we are going to use a circuit called as adder, which is going to be in full adder, half adder. We did that recently. Right. Then whenever we have 75 minus 19 to be performed by the computer, this is really a subtraction. So to do the subtraction, we need to have another circuit called as subtractor. Now, do I need to have a subtractor, or can this operation be performed as addition using the adder itself? That's enough. This is going to be minus 19 is going to be presented as a 2's complement. Then that value added with this without doing subtraction. And now the benefit is, it is possible to this answer, it is possible to handle the subtractions by the CPU, comma ALU using the same circuit adder to make the CPU less complex. It makes the CPU less complex all the time, since possible to handle all the subtractions even in the form of the addition. Now I think the things are clear. So in this part E answer ne. Right. Then part F, consider the value 45.375 represent the above value in binary. Now part F, now this is okay. So I don't want to explain the things since you have the theory background, just keep summarizing the areas only. Next the other question, F. Consider the value this, represent the value in binary, calculate the mantissa of this for the IEEE, calculate the exponent, write the final answer in 32-bit. Then I have to do this conversion into IEEE 754 format slowly. 45 375 ne. 45 375, this is going to be a positive value. Since it is positive, what's going to be the sign bit? Sign bit is going to be 0. Okay. Now the first work I have to do is convert this into binary. Okay. When converting that into binary, I have to treat the whole part and the fractional part separately. And now first I go to 45 to be written in binary. That's going to be 32, 16, 8, 2, 1, 18, 4, 2, 1. 8, 4, 2, 1. To complete 45, 32, 32 gone means 3, 13, 8, 12, 0, 1. So then that's what the 45 in binary is. Now I want to get the next part, the fractional part, 0.375 to be converted into binary. How do you do so? Multiply that by 2. 0.375 multiplied by that by 2 makes the answer like 0, 5, 7. This is 0. Right. Then the next round 0.750 into 2. That's going to be 1.500. Then the next 0.500 into 2 is giving 1.000. Fine. Now these are considered from top to bottom as the fractional answer. And final binary answer is going to be 0.011 in binary. Then finally I am going to get the answer. The first part is represent the above in binary. And for the part 1, it says 45.375 is 101101.011. Okay. Then second one, calculate the mantissa. And to calculate the mantissa, what I will do is I am going to write this in the standard format or normalized version. So that I have to bring the decimal place 1, 2, 3, 4, 5 places left. Now 1.0110111 into 2 to the power 5. Now in it, we are going to consider this as the mantissa, whereas this is going to be the power of the value. Now they ask the mantissa, simply I can write the mantissa at this moment as 0, 1, 1, 0, 1, 0, double 1. Right. Then by the third part, calculate the exponent. And how to go to the exponent? Exponent is the bias 127 plus the power. So here power is going to be 5, then altogether he is going to give you how much as the answer? 1, 2, 3, 4, 5, yes. And that's going to give you 132, isn't that? Then I have to write that in binary. So 128, then 132, 128 gone means we need to have 4, ne? 128, 64, 32, 16, 8, 4, 2, 1. So this is what the exponent is. Alright. Now we have to place the things in the order, the sign bit. So they want the exponent, that is the answer for the third one. Then the order is sign bit, exponent and mantissa. So in that order I can complete the final answer. Expect as the fourth one. Yes. Then I may write the fourth answer somewhere here. Sign bit is going to be 0 since it is positive. Then we write that as 0. And after that, you have to keep the exponent. So this is what our exponent is. 1, 1, 2, 3, 4. 1, 2, 3, 4, 1, 0. And after that, I have to keep the mantissa. 0, 1, 1, 0, 1, 0, 1, 1. And then you have to complete the 32 bits with zeros. Then I may count 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then these are the final IEEE answer which is available under the fourth statement. Hope that no issue at all. That's the question number 2 in it. Then the last question, the question number 3. This is okay. I just keep doing that. That's a normal thing what we have done in our lessons. We did many questions as well. Then just test that in the paper. Very simple thing. Really, it's not a question, right? Right. Now, question number 3. Construct the logic circuit for 2-input XOR logic gate using basic logic gates. XOR gate, how it is made with the basic logic gates. They are the exclusive OR gate. The symbol is like this. How it is going to be made with the basic gates. Here we need to have 2 AND gates. These are A and B. So A channel comes like this. B channel comes like this. And the inverse of B is submitted to the next. And inverse of A is submitted to the other one. Then finally, both of them are joined through the OR gate to make the final F. This is what the question number 3, part A, the first section. They ask the logic circuit for XOR gate. Then the next one, derive the Boolean equation for 2 input XOR gate using basic expression. Using that circuit, you are going to get the Boolean equation for this circuit. And now, what is it now? Now we'll just say that A and B bar is there, and this produces A B bar. This channel is going to give you A bar and B, making it as A bar B. Finally, they are summed together, making the answer as A B bar plus A bar B. So then that's what you need to obtain. Then for the second one, the answer is going to be A B bar plus A bar B is expression for the 2 input exclusive OR gate. Right. What is next then? Consider the Boolean equation given below. Construct the logic circuit for the above equation. Now for this equation, now you want to get the circuit. Yes, I'll go to the board. Yes. The equation is given like x equals P Q bar P plus Q bar R then Q plus R bar. P Q bar P Q bar P plus Q bar R P Q bar, right, that's fine. Now what we need is construct the logic circuit for the above equation. Then for this we have to go for P, Q and R, all three are there. Then I may use the input channels vertically, that would be convenient for me. Now when you develop the circuit, the first priority goes for the brackets and O. And now I am going to implement this bracket, the first bracket, P inside that dot and plus is there. First priority goes for the dot operator, Q bar and R goes through the AND gate. This makes Q bar R. Then the P input goes there to complete the bracket, submitting them through the OR gate. P plus Q bar R. Then the other bracket Q plus R bar, and here we have Q, then R bar goes through the OR gate. Q plus R bar. And also I want to prepare P and Q bar. P, then Q bar. This is Q bar, this is going to be P. Now what happens finally? Here we have P dot, Q bar dot, this bracket dot, this bracket, isn't that? Finally, this has to be a 3 input AND gate. So one section is this whole thing, other section is this bracket whole thing, other one is P directly, other one is Q bar directly, isn't that? Now here we don't have any other priority, all three are dot continuously. They don't, among them we don't have any priority. And on the correct circuit diagram is joining them together through a single 4 input AND gate. So it's multiplying this section, and then from here it's going to be P, from here it's going to be Q bar. No any priority for this. Some people have given a separate AND gate here that is joined to this. Really strong, but I have given marks, but this is a correct version for the expression to be implemented. Right. Then construct the truth table for the Boolean equation. For this equation, we want to get the truth table. So then that's really simple. Yes, I'll go for the next page. X equals PQ bar, P plus Q bar R, and the next bracket Q plus R bar. Then for this we want the truth table. And truth table goes with 3 inputs A, B and C. Now we want to complete the intermediate columns. What are those intermediate columns? I want to prepare Q bar here. Q bar is required. And also I want to have R bar prepared. R bar. Now I may prepare the brackets here. Q bar R, and the other one is Q plus R bar. Then we want the PQ bar. Right. Then finally we can have the X output, that's going to be PQ bar. No, before that we want to prepare P plus that thing. Ne? This bracket have to be prepared. Ne? P plus Q bar R. Then you can go to the final output. X is PQ bar, the first bracket as well as second bracket. Now the values are going to be 0, 1, 0, 1. Then Q bar value is opposite of here we have PQ, not ABC. PQR, right. Now we want to go for Q bar here, opposite of Q, 1, 1, 0, 0. Here 1, 1, 0, 0. Then R bar is the opposite of R, 1, 0, 1, 0, 1, 0, 1, 0. Then Q bar R. So then now I have to consider Q bar as well as R, these two columns. So Q bar and R dot together. Then this is 0, this is 1, 0, 0, 0, 1, 0 and 0. Then the next is going to be Q and R bar. Q and R bar. Now not Q, it's going to be Q and R bar. Has to go with O operator. O nang if any of the inputs are 1, output is 1. Here 1, here 0, here it's 1, here it's 1. Q and R bar 1, metana 0, metana 1, here it's going to be 1. Then PQ bar, now I have to consider PQ bar, P and Q bar dot operator. Then all these are zeros, the first 4 are going to be zeros obviously. These are ones, Q bar, then these two are going to be 1 and 1, whereas these are going to be zeros. Then P plus, next is P plus, so P plus Q bar R. So this has to be plus operator now. May become plus window. So this is going to be 0, here it's 1, this is 0, this is 0. Then all these are ones, therefore the answer is going to be ones all the time. This plus operator, O operator. Now finally we have to dot them together. Now I have to consider P. I have to consider P. Then PQ bar, this one, I have obtained that already, therefore no need to go for that. Okay. Then PQ bar, then the first bracket, this bracket as well as this bracket. All three should be dot together. If any of them are 0, answer is 0. This is 0, 0, 0. This place is going to be 1. This is 0, 0 and 0. Only one place it has the answer as 1. Yes, that's the correct answer, right? No issue. Fine. Now this is a truth table for the expression. Now they are very simple things, right? Then still I found that how people lost marks on this. That means you didn't care about this very much. They are very simple things compared to the ones to be available in the future. Now I'm not scaring you. Really, there are much more things than this. Therefore, you must be fluent on this. If you have played, if you didn't care about studies, now this is triggering you that your work is not enough at all. Not only in my subject, I don't know with the other subjects. If you have faced the term test in your other subjects, still that may be the pathetic situation if you didn't work properly. So this is to motivate you that if you have obtained less than 50 for your term test, that's very poor. It can't be. Right? Okay. Then we'll go to the next part of this question. Construct the truth table for this one. Okay. Then it says that derive the POS equation for the truth table given below. Now we are supposed to derive the POS equation. Product of sum. If you are going to get the POS for this truth table, we have to consider what? Once the zeros there. Zeros are considered in the output. Now, now you all are fluent on this, right? Now this is 1, 0. And now how do you represent the input combinations? Whenever you have 0, we write it as the variable going to be A plus B plus C bar. Then for this, we are going to write that as A plus B bar plus C bar. Then this is still written as A bar plus B plus 0. This is going to be written like A bar, B bar, C bar. And our final expression is going to be x equals the product of these sum terms. A plus B plus C bar. So I taught this how it is to be obtained. Then this is not the time to teach the theories. And the other two are there. A bar plus B plus C. Then A bar plus B bar plus C bar. So this equation as they expected. Then construct the logic circuit for the above POS equation. Now you are supposed to get the circuit for this. How do you get the circuit? I think I have space there. Okay, I'll try to manage the space by drawing it. Right. Now here we have to have the channels A, B and C, the input channels. Okay. First I have to implement this bracket, O operator. A channel goes from A, B and then C bar through the NOT gate, then sending them through the OR gate. Okay. Now the second bracket, A, B bar and then the C bar, still sending through the OR gate. Then after that, the third bracket is going to be A bar, then B and C sending through the OR gate. Then next, the last one, A bar, then B bar and then C bar. So all are sent through the next OR gate. Then finally all of them are dot together, and on these output channels are collectively sent through a single 4 input AND gate to make the final expression x. So then the other questions, right? Then I wonder why you could not get the full marks, right? Now hopefully if you have the term test recently in the school term test, definitely there will be more than the one what we have added here. So then recently we have completed, now in our normal theory classes by we people, we have completed the circuit designing part, Carnot maps part, even the Boolean theorems part. Now compared to that, this is really nothing, right? Now really in this paper, there's no any big magic, then you should score more, right? So then what I want to say is, if you didn't score more, you are very poor. Improve, work, you have enough time to improve. So then that's the motivation I can give you at this level, right? Okay, then now I think the questions were discussed successfully, and then hope that you are clear with your doubts, and if you have further inquiries, you may talk to me. So I'll help you even through our WhatsApp numbers, or yes, if you are attending to my classes, no issue, I am open to you during the physical sessions or online sessions. Contact me to clear your doubts, right? Then we'll keep another term test in the near future. So once these are hopefully in the next somewhere like June or July, that will cover many more things. So in our sessions, we are going to start the operating systems recently as well. Now we are on the way to discuss the past paper questions.